Hello friends, in the last video we looked at the poor man's encoder. Now nothing is complete till the time you understand at the absolute bit and byte level what is happening inside the encoder. And this is where in this video we will spend some time doing a GDB based analysis of the poor man's encoder. This free video is sponsored by SecurityTube Trainings. Please have a look at our offerings at securitytube-training.com. Okay, so if you're not familiar with what is the poor man's encoder, I think you need to go watch part 3. This is part 4. Right, so let me jump right back in. And this is where we left in the previous video. Let's pick up where we left. Now what I'm going to do is, I'm going to run shellcode but inside GDB, set disassembly flavor to Intel, and code was the variable in which our shellcode was placed. So let me go ahead and set a breakpoint there and let me run the program. Disassemble, and we see a lot of stuff in here, right? And if you notice, we have our jump which was there in the previous video. If you recall, here is basically our call, and from this point onwards is our inverted shellcode, right? And we could verify this. Let's copy and let me do a shell cat. I think it was decoder.nasm, and so we have 8t cd blah blah blah. Now let me actually do a dump in memory at that location which we just located. And if you notice, we have 8t cd 40 80 blah blah blah, 8t cd 40 80 blah blah blah, right? Oops. Okay, so what I want to tell you is what's really happening in here, because the bswap command is pretty interesting. So let's go ahead and set basically step by step. Just for the first one, I'm going to write a quick hook so that we get a disassembly at every line when we step through the program, right? So we call the call right now, then we move on to pop. Now the XOR happens, and you just have to follow the left hand little arrow in here. This is the next instruction to be executed. Right, and now we are moving this to start the loop. And we are just about to run the bswap command. So if I do a print in hex on the contents of EAX, this is the content. And if you kind of go back here, it's basically, if you notice, what's really happened is we've kind of read these 4 values in, right? Now let me run the bswap command. Okay, and now if we look at the register, you would actually notice that this is currently in absolute reverse order. So right now it's 80 CD 40 80, while here it was 80 40 CD 80, right? So we've gone ahead and reversed this byte by byte, so the lowest becomes the highest and the middle two swap their positions. And this is exactly what we needed. Now what I'm going to do is, after all of this goes through, let's just look at how the decoded shellcode would look here. So the decoded shellcode would begin its call right here. Let me set a breakpoint in here. Continue. I've hit the breakpoint. And at this point, let's look at what is there inside ESP, right? If you notice, this values, all of them here basically are not going to change, simply because we aren't doing any changes here. Rather, we are pushing the changes onto the ESP, which is basically the stack, right? So let me go ahead, disassemble the stack, and there you go. We're gonna disassemble a couple of more instructions. Here it is, and if you compare this with the original shellcode final.nasm, you'd see that this is pretty much the same, right? You have push, EB, EX, CDQ, blah blah blah. This is basically the exact same thing in here, right? Which means the code has been inverted and is ready right now for running. And you could just do a continue, and you would actually see that the program would run. Now don't worry about it not going in here. Let's exit the process, and there you go, right? So this is how we can go ahead, decode the shellcode, put it all on the stack, and then point back to the stack. So hopefully this was clear, and I would recommend that you go ahead and try this yourself, simply because that is the best way to learn. Now, if you have any comments or feedback, please post them down below. Post interesting scenarios if you like, and I may take them up. And of course, help other people in the comment thread. Self-promotion, I think we have a Linux assembly expert, 9 hours of videos on assembly language and shell coding. Definitely have a look. There's around 1 hour of sample videos on the course page. That's all, guys. Thank you.